Hey, we are going to look at a technique called as Granger causality, and it's one of these techniques that gets thrown around in literature quite a lot and also in a few articles. So let's understand if this is actually useful in our MMM. What are the downsides of using this? Is it useful in other causal impact or incrementality? Let's look at this. So I like to think of Granger causal method as helping mainly in two main streams within marketing science. First one is with selecting some variables, and the second one is the temporal patterns, or actually looking at what sequence of events matter. So, for example, a test that checks if X happens before Y and if it helps in predicting it. That's it, right? The even though it has the name causal within it, Granger is not actual causation. It's checking for it. It's looking for correlation and some prediction. That's about it. So, like we say here, we're just predicting. That's it. No causation, no magic, just temporal correlation with some extra step. So here's a reality check that I want you to take away from this, even though this video is about Granger causal, and I encourage you to learn more about it and understand what are the goods and the bads of it. But 95% of the time you won't need this. There's only a slight like 5% of the chance where you might use Granger, and that too if you're in a time crunch, because there are other methods that do exist where you don't even have to look at Granger. But if you're in time crunch and you have to get some outputs, then Granger can be your first step. So here's an example of what you might look for, right? So here's the rooster and a sunrise. So whenever the rooster crows, there's a sunrise. But there's of course there's that correlation, but does it cause it? If you look at Granger, it says it is significant, and that's all it says. It's significant or not significant. It doesn't give you the magnitude, which most of the time in marketing science you need. So here it says significant, but does rooster cause sunrise? Obviously not. So you have to take it with a salt. So a marketing equivalent of that is Google searches leads to purchases. Granger says it is significant. Wow, that's good. But do searches actually cause purchase? Maybe not. There might be few other steps in between. So here are the better alternatives, right, for Granger. I know we haven't even discussed about Granger and we're already looking at alternatives. It's because there are various other alternatives to Granger causal. But like I said, it's a good starting place if you want to just look at things. So first thing is if you want to find a lagged structure within your marketing model. And this is typically done by ad stocks within MMM. So you find the point at which there is a significant effect for that channel and then how it decays over time. So there are better alternatives for in MMM. There's ad stocks here. There's cross correlation, which actually shows magnitude and not just yes, no, because like we saw, Granger causal, it just shows yes or no, significant or not. That's about it. And then the second thing is selecting variables. So this is where you can use this really quickly. Test each variable separately. So let's say you built up your MMM variable list now, and then someone comes in, hey, I want to add this economic activity that just happened. And you could add that and then run the MMM completely and then get the coefficients. But the other way is you could just run a Granger causal on that and then see if it has an effect on sales and decide. But there are other variable methods as well, like Lasso regression, that you can use if you're just selecting variables. Let's say you have hundreds of variables and you obviously don't want to put all of them into MMM and overfit. You only want the ones that are really important. So in that case, you can use Lasso or ridge regression, but Granger causal can also give you that. We'll see that in a second. So when you're trying to prove causation, Granger approach, it just shows the temporal precedence. So temporal precedence is just a fancy word for saying, hey, what happens for a particular event? So if you're building like a DAG, directed acyclic graph, for your causal analysis, then doing a Granger causal is a good starting point. Like I said, it's a starting point. You obviously need to layer on the domain knowledge and your business to actually make it much more useful. But the other alternative is just to run experiments if you were purely trying to prove causation. And if you're trying to measure ROI, it can't do it. Incrementality test can. Like I said, Granger causal is just an yes, no, significant or not significant kind of a thing when it comes to analyzing these things. So here's one thing where actually Granger causal is useful, right? The competitive dynamics. So test who leads whom. So if you're Nike and you change your price and you're Adidas and you saw them change the price as well, then who led the price change and who's copying, who's following, and all these things. If you want to look at the competitive dynamics, Granger is actually good at that here. So one of the few use cases where Granger is actually useful. Yeah, like I said, this scenario, you use Granger selection really happens. What happens in practice is you include everything that the client thinks and what you think. And if the competitor data is available, you add that seasonality, holidays, you add regularization to kill weak variables. You can do that as well and check business logic. Everything is done. And then someone comes in and says, hey, should we add weather in there? And that's when you run just a Granger test on weather if it's able to predict the sales and you get a metric there, but then eventually you include that anyway because the CEO insists include weather in there. So that's the reality of using Granger. But let's get to some simulation stuff. So let's imagine you have hundreds of variables and you click on Granger causality and see how long this takes. It can usually take up to 50 minutes, or I mean, it doesn't have to be that. It takes a really long time compared to the other methods that we have here. The idea is if you had all these variables that you could include within your MMM, but you have time constraint and you really want to give some result out, then you could use Granger causality. Although when I say time crunch and then we have to spend 45 minutes, doesn't make sense. But anyway, so this technique does exist. So it can give you, hey, look at TV spend, gas price, competitor spend, weather, email clicks, and so on. So it gave you like 6 out of 9 useful variables over here. 9 was selected out of 100 of variables. So it's mostly looking at the p-values. So that's a good one. And then if you want even faster, you can use lasso regression. So this only takes 30 seconds. This gave you 12 variables instead of 100 coefficients plus importance. So this is the key here, right? It also gives you coefficients. And even better here is it handles multi-collinearity, which is what we saw earlier in the video. But this is a key problem that we have within MMMs, and Granger is not able to solve that. And it also gives you the actual coefficients that you can use for prediction, whereas Granger is only saying yes. Similarly, like Lasso, there is ridge regression as well. And then there is the business logic, which can be perfect, nearly perfect, because you know your domain, you know your business, you know what affects the sales, even the stuff that we spoke about here with competitor dynamics. You probably already know what is happening within your industry and how the competitors are react to each other. So you don't need a model to tell you all that. But if you have something really, really complex, then you can probably use it. And learning about Granger causal isn't that difficult either. If you come to the stats model library within Python, it's just a simple function that you can just call and be done with it. And you also have some examples down here that you could run as well. So if you have, let's say, a time series kind of a data, so if you have a time series data like this, then all this is doing is it's considering lags of 4 days. So if this was today, then it goes for yesterday, the day before, and the day before that, and then day before that. What kind of lag is actually useful here, and when the impact actually starts kicking in. Or if you want to just look at the fourth lag and just don't want to consider any of this, then you can use this formula over here. But it's also good if you're looking at, let's say, incrementality test, and if you want to look at, let's say, YouTube lag. So you start YouTube ad sometime here, and then there is no effect, and then suddenly there is an effect. So if you want to calculate all of this, then you can see, okay, 1, 2, 3, 4, fifth day, and then you can set the lags here. And then whenever you get the lowest p value or the most significant value, then that could be the number of days at which the campaign actually ends with some effect. Other ways of doing this is just to be visually looking at something like this, which is a cumulative plot. If you just keep plotting the incremental impact, you see a cumulative plot at certain time, it just kind of change direction, and that could be one way of looking at it as well. But if you want a much more mathematical way of doing things, and that could change your causal. I know we've spoken too much about why it's not useful that much, but it is good to know this technique sometimes. And in the rare cases, the 5% of cases where it is useful, use it. Or if you just want to sound more smart with your stakeholders, then of course use this. And whenever you say Granger causal, people will be like, oh, that is something smart.